Hey everybody. So we're getting into 10.5 today using square roots to solve quadratic equations. All right. This lesson is mostly going to be a bit of review, and it's going to help us lead into what we're going to do in the next section. Okay. But before we get into this first slide here, I'm going to have you guys try a quick warm up here where I'm going to have you simplify two radicals or two square roots. All right. And I'm going to recommend using a factor tree on these. All right, if you guys remember, the first thing you do is you're just looking for two numbers that multiply to get what's underneath the radical sign. All right, so start with that and then continue to break them down until you have a bunch of prime numbers. And then, if you guys remember, we pair up numbers that come out of the radical. What doesn't pair up stays inside. Okay, so try out A and B and see if you can remember how to do those. Okay, so on number or letter A, two numbers that multiply to get 24, there's a few options. The first thing that comes to my mind is a 2 times 12. Okay, 2 is prime. It cannot be broken down. 12 can, though, right? You can break it down into a 2 times 6, or you could do it 4 times 3. It doesn't matter. But when you break something down, cross it out. Okay, again, 2 is prime. 6 I can break down into a 2 times 3, cross it out. 2 is prime, and 3 is prime. So what we did is we broke this thing down into its prime factors. And if you guys remember, the idea is that numbers that pair up, two of the same numbers get to come out of the radical, and things that don't pair up stay inside. So this pair of 2's right here means a 2 is going to come out of the radical. There is not another 2 to pair, but this one is the same thing with the 3. There's not another 3. So those two things are going to stay inside the radical. All right. And, everything is always being multiplied together. So the 2 stays inside, the 3 stays inside, multiplied together, and I get a 2 squared of 6. Okay, and that is the simplified form of this radical. They represent the same number. Okay, let's try to, with number or letter B here, same idea, 32. I'm thinking of two numbers that multiply to get 32. Again, there are options on this. I'm just going to go with 4 times 8. Okay, so there's the first two numbers I thought of. 4, I can break down into a 2 times 2, cross it out. 8, I can break down into a 2 times 4, cross it out. These 2's are prime. This 4, though, breaks down into another 2, cross it out. Okay, so we broke this thing down into a bunch of 2's. Let's start pairing them up. This pair of 2's pairs up. I could pair up these two here or these right here. I'm just going to do these because I like to go left to right. This one doesn't pair up. Okay, so what this means, this pair of 2's means a 2 comes out. This pair of 2's means another 2 comes out. There's the good old bell. And this 2 is left inside the radical. Okay, so multiplying them together, I get a 4 square root of 2. Okay, so that's just a little reminder on simplifying square roots or radicals. So let's get into what we're doing today. Okay, today the form of our equations are all going to look like this: ax squared plus c. If you notice, this is missing the bx value that's normally in the middle of our quadratic. All right, so I'm going to have you guys go ahead, get the title, copy this slide, and then we'll get into it. Okay, so yeah, solving this thing, you guys will see this, like I mentioned before, this is all review. This is stuff we've done in the past, but I thought it was worth looking at it in the context of quadratics, because that's what we've been doing this section is, graphing quadratic functions. And you'll see why this helps us in our next section when we get to it. Okay. All right, so hopefully the bell's done. So yeah, let's go ahead and copy this example, and we'll try this one together. Okay, so here's the good news about these problems. Since we just have an x squared, ultimately what all of these problems come down to, or most of them, is isolating that x squared and then solving for x by taking square root of both sides. All right, so that's the first thing I'm going to do. I'm going to go ahead and isolate this thing just like I would solve any other normal easy equation. First thing, get rid of this 8 by adding 8 to both sides. Okay, I have a 2x squared equals positive 8. From here, dividing both sides by 2, and I get x squared equals 4. Okay, last thing is solving for x, getting rid of this power of 2, or undoing squaring. And if you guys remember, the opposite of squaring is square rooting. Okay, those cancel each other out, have to do it to both sides. Okay, So these are gone, and I get x equals the square root of 4. All right, here's the thing. Normally, when we deal with radicals, we kind of ignore the negative one, but technically, when you take the square root of anything, you're getting the positive and negative of it. Okay, the square root of 4 is positive 2 as well as negative 2. So the way we end up writing this, just to show it's positive and negative, we do plus or minus 2. Okay, and another way we could write it is we could say x equals positive 2 or x equals negative 2. We could do it that way as well, but this kind of is, I guess, a more concise way of writing that. Okay, so there it is. We solved our quadratic equation. All right, cool. So let's keep moving. All right, let's try another one of these. Let's solve this quadratic equation. Go ahead, copy it. Okay, so pretty simple idea. Again, since there's just this one variable, we can just isolate it. Unlike other quadratics, I just want to point out where we had to like factor and all that stuff. These, because there's just that, I guess that ax squared value, we can treat it like a normal equation. So anyway, I'm going to go ahead and add 18 to both sides. Okay, so I'm getting m squared equals negative 18 plus 18 gives me 0. Right? Then from here, taking the square root, getting rid of that power of 2, both sides. Those cancel. I get m equals plus or minus the square root of 0 is 0. There's no such thing as plus 0 or minus 0. So we're just writing one answer, m equals 0. Okay. All right, let's try one more of these. Again, the directions keep repeating themselves, so you don't need to write those over and over. Go ahead and copy this one, and then we'll try it. Okay, so again, we can just solve for b here. First thing, getting rid of positive 12 by subtracting 12. 3b squared equals 6 minus 12 is negative 6. From here, let's go ahead and get rid of this 3. It's being multiplied, so we divide both sides. And I'm getting b squared equals negative 2. Okay. Last thing, undoing squaring by square rooting, right? Taking the square root of both sides. Okay. Here is where we run into an issue. If you guys remember, we cannot take the square root of negative numbers. All right. That doesn't exist because think about it this way. Any number times itself will always give you a positive. Okay. If I do negative 2 times negative 2, I'm going to get a positive 4. And if I do 2 times 2, I'm going to get a positive 4. All right. So there's no way for us to break this thing down, or I guess rather find the square root of negative number. So because of that, this is one of the examples of a problem that is no solution. Okay, so look out for that. If you ever end up with a negative underneath a radical, your answer is no solution. Okay, so just to kind of sum up these 3 examples, going back to the first one, we can, after doing a problem, typically you will have 2 answers. This one was a positive 2 and a negative 2. Though sometimes if you have the square root of 0, you'll just have a single answer. Or sometimes if you have the square root of a negative number, you will have no answer. Okay, so that was kind of the theme of those 3 examples. All right, so I'm going to have you guys go ahead and try one of these on your own, and then we'll keep moving. Okay, so on this one, I'm going to go ahead and solve for x by first getting rid of minus 32 by adding 32. So I have a 2x squared on the left. On the right, I have 32. Divide both sides by 2, and I'm getting x squared equals 16. Okay, now I can undo the squaring with square rooting both sides. Don't forget the plus or minus in front of that radical. Okay, because when I go to do this, the square root of 16 isn't just positive 4, it's also negative 4. Because again, negative 4 times negative 4 would give us positive 16. All right, so it's a plus or minus 4. All right, so let's keep moving along here, and let's take a look at ones that have us run into fractions. Go ahead and copy this. Okay, so take a square root of a fraction. Let's see what happens here. So solving for x, I just need to get rid of this 4. It's being multiplied, so I'm going to divide. And I'm getting x squared equals, and I'm getting a fraction here. I could divide these, but I don't want decimals. I want to just leave this thing as a fraction, 9 over 4. Okay, well, what's going to happen here? Well, to undo squaring, we're going to square root both sides, plus or minus. Don't forget that. Okay, if you guys remember back when we were dealing with a lot of fractions and all that stuff, if we took the square root of a fraction, what that means is we're taking the square root of the numerator over the square root of the denominator. Okay, that's really what this represents. And again, we don't want to forget the plus or minus. Okay, so this kind of works out nicely. The square root of 9 is 3, and the square root of 4 is 2. So we're getting a plus or minus 3 over 2. Okay, so that's just kind of just a little reminder. If you ever end up with a fraction, you take the square root of the top and the bottom, and then there it is. And sometimes you'll end up with a radical in the bottom that you have to get rid of, but I'm going to try not to give you anything that goes too much crazier than what you just saw here. All right, let's try one more together, and then I think I'll have you guys try one last problem. Let's see what happens on this thing. Copy it. All right, so solving for x, I'm going to add 11 to both sides. Getting 3x squared equals, what is this, 24? From here, getting rid of 3, dividing both sides. Getting x squared equals, this actually divides evenly, right? We're getting a nice clean 8 on this. All right, and then solving for x, get rid of squaring by square rooting, plus or minus. By the way, this should technically also have a plus or minus, but I normally don't do it because it just, cancels out immediately. So sometimes I forget to do that. Okay, so we're getting x equals plus or minus the square root of 8. Here's the thing. This is not a perfect square. So this is the type of problem where we would want to break this down using a factor tree, just like we did in our warm-up. Okay, so first two numbers that multiply to get 8, I think 2 times 4. 2 is prime, 4 breaks down into a 2 times 2, cross it out. All right, so now pairing off numbers, it looks like we have a pair of 2's that comes out and a 2 that stays inside. So we're going to get a 2 square root of 2. Okay, and don't forget, technically it's plus or minus. So that is our simplified form of our problem here. Okay, so if they ever ask you to simplify radical, remember, that's all you have to do. It's really nothing too crazy. I could have also typed that into a calculator and got a decimal, but we wanted to get nice, I guess, simplified answers. Okay, so last thing, I'm going to have you guys try a couple of these, and then we'll be done here. Okay, so on letter A here, first thing, getting rid of 25 by dividing both sides. Okay, I have x squared equals 16 divided by 25. That doesn't divide evenly. I'm going to leave it as a fraction. Okay, and you can probably see where this is going. Now, to get rid of the squaring, we're going to take the square root, both sides, plus or minus. Those cancel. And I have the square root of a fraction, which, if you guys remember, means I take the square root of the numerator and the square root of the denominator. Don't forget the plus or minus. Right? And yeah, these are nice perfect squares. So I'm getting a plus or minus. Square root of 16 is 4. Square root of 25 is 5. There it is. Okay, letter B. Solving for x, I have this 4. I'm going to get rid of it by subtracting. Okay, so I have x squared equals over here 31 minus 4. What are we getting here? 27? All right. So last thing, getting rid of that by square rooting both sides. And I'm getting x equals the square root of 27. Here's the thing, and I'm going to erase this because, again, not a perfect square. I need to break this thing down. Okay, so two numbers that multiply to get 27. I think 3 times 9. 3 is prime. 9 breaks down to a 3 times 3. All right, and there we go. Oh, don't forget, cross it out. Okay, so pair of 3's means a 3 comes out, and that 3 stays inside. So I'm going to get a 3 square root of 3. Don't forget, sometimes I forget to write it up here. Technically, plus or minus. That's what x equals. Okay, so yeah, I kind of went through this quick because, again, it was review, solving equations. We've done this a lot. This is going to kind of help us remember how to solve when we have radicals. You'll see in our next lesson why it was good to see this before we went into it. Okay, so that's that, guys. We'll see you.